Hello, let's continue our Sudoku adventure with Remotion by Chili. So we have normal 6x6 Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these purple lines/loops in the grid. These are renbands. So digits on a renband line form a set of non-repeating consecutive digits in any order. So this renband line touches 4 cells, so it's going to need 4 digits on it, and they all need to be consecutive. So we could do 1, 2, 3, 4, 2, 3, 4, 5, or 3, 4, 5, 6. But the order doesn't matter. So let's say we choose 2, 3, 4, 5. That's how it ends up being. Excuse me. That's how it ends up being. We could put them in order, but we could also, swap them around. I'm not sure how this could be out of order as a loop. But yeah, 2, 3, the order doesn't matter is the point. It doesn't matter where you put them, just that when you take them as a whole, they are a consecutive set of digits. All right, and we also have remote sums. So some cells on renband lines are surrounded by dotted lines. These are cages. So a digit X in a cage points to a second digit Y located X cells away from the cage along the same line that the cage is on. Oof, that's a mouthful. The number in the top left corner of the cage indicates the sum of X plus Y. So let's go through an example. If the digit in row 1, column 4 is a 2, then exactly 2 cells away on the line, which is so we're following the line 2 cells away. So we're not doing remote sums like on rows or columns. We're doing it on the line that it's on. So we go 2 cells away, which is row 2, column 2. Then this has to be a 3 because 2 plus 3 is 5, which is the clue on the top left. Note that if lines are loops, then a remote sum cage can point to itself or can indicate a distance that requires traversing the loop more than once. So if we were to put a 6 here, then we could count 1, 2, 3, 4, 5, 6, and that would end up here. Or we could put a 4 here and it would end up referencing itself. All right, cool. Thank you for the detailed example there, Chili. That helped a lot. So there is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. I think I want to start with this 3, because it's definitely a 1 or a 2, because it's going to be adding with another 1 or 2. But that means that there is a 1 on this line. So if there's a 1 on a renband line, then it has to be a minimal line. So all of these cells are from 1, 2, 3, 4 only. Now this one is 8. And on a 1, 2, 3, 4 line, the only way we're adding to 8 is if it's 4 plus 4. So it's got to be referencing itself, and luckily 4 is the length of the line. So we end up with the 4 there. There's going to be a 3 in one of these 2 cells. And then this is 1 or 2. Oh, this can't be 2 actually now, because 2 would reach the 4, and that wouldn't add to 3 anymore. So this has to be 1, which is going to point to one of these 2s. We don't know which one. And then, so this ends up being a 2, 3 pair. Okay. And that resolves this whole line. I guess that was a good place to start. Okay, so this line is 6 cells long. A 6-cell renband just has all 6 digits on it. So it's kind of like an extra region. So it's going to need a 4 on it, but none of these can be 4. So this ends up being a 4. And so now we have to go 4 away. 1, 2, 3, 4. This ends up being a 1 to add to 5. And then these are the other digits that aren't 1 to 4. So these are 2, 3. I counted this wrong. It is not 6 long. I don't know how I even specifically counted it. Anyway, it's 5 long. I still think it needs a 4 on it though, because if it's 5 long, it can only be missing the 1 or the 6. It can only be missing one of the extreme digits because it's either 1 through 5 or 2 through 6. So it still does need a 4 on it, which goes there, and this still does need to be 4 away, which puts a 1 there. So I was correct, but for the wrong reason. So I'm glad I backtracked there. But that means there's a 1 on it, which means there's no 6 on it. So where does 6 go in this box? It goes here. And then these are going to be from 2, 3, 5. Okay, now this is a 2, 3 pair. Do they see anything of interest? Just this cell and this cell. Darn, okay. I was hoping we could eliminate 2, 3 from any of these. We do end up with a 2, 3, 5 triple here though. So first of all, that means the 5 is in one of these 2 cells from our triple, which means this isn't a 5. Or you can think about it as this cell is the same digit as this cell because it has to go in the box somewhere. And then over here we need 1, 6 pair. Okay, so this is going to be from 2, 3, 4, 5, 2, 3, 5. Yeah, let's fill that. 5 is up here. Okay, we probably need to look at more of these lines. 10 is really interesting. I know I'm going to need a 1 down here. 1, 2, 3, 4 is no good. Because I can't get 2 digits of 1, 2, 3, 4. In fact, the 2 digits that are going to add to 10 are either going to be 6, 4 or 5 plus 5. The only way it would be 5 plus 5 is if the 5 were here and it's self-referenced. But unfortunately, it's 4 away, not 5 away. So this is going to be definitely a 4 or a 6. And this line's going to have a 6 on it. Now, if this was a 4, it would actually reference itself. So it actually has to be a 6. And then this is 6 away. We counted that earlier, actually, but 1, 2, 3, 4, 5, 6. Yeah, so this is 6 away. So this is the 4. And then it can't have a 1 on it because it has a 6 on it. So that's a 1. And then this fills the gaps, 3 and 5. Very nice. Okay, that 3, 5 pair means 2 goes here. And that means this is a 3 because of our Renban. And that resolves a bunch of stuff. This is a 3 as well. Remember, these were the same. Okay. Cool, that's good progress. This line is 5 long as well. 1, 2, 3, 4, 5. So it's only missing 1 or 6. So what can we say? Maybe filling this triple will help. We need 2, 5, 6. Okay, we know the 6 is down here somewhere. Maybe the 7? In a 6x6, 7 has the most ways to add to it in 2 digits, because we can do 1, 6, 2, 5, or 3, 4. So it doesn't actually exclude anything. If this were... Okay, this can't be a... this can't be referencing this cell, I guess is the way I want to put that. This could be a 1 if we put a... Actually, we can't put... Okay, yeah, this can't be a 1 at all, because it would need to join a 6, and neither of these can be 6. Because the 6 is down here for this column, so this can't also be 6, and this sees a 6. So this is not a 1. So this is going to be referencing this cell or this cell as a 2 or a 3. If it was a 2, we would need to have a 5. That's possible. If it was a 3, we would need to have a 4, which is not possible. So this is 2 and 5. This is 2 and 6. Very nice. I like how that resolved. That's 5 and 2. We still don't know. I mean, 2 and 5 were both required on this line. Only 1 or 6 is omitted, so we still don't know what kind of line it is. We are going to need a 5 in this column, though, and that goes here, and then the remaining digit is a 6. And now we know there's a 6 on it, which means there's no 1 on it. So these are the 2 digits that are missing, the 3 and the 4. Not resolved, I don't think. Okay, but these cells see the whole 3, 4 pair, right? They see this 3. If this was 3 and this was 4, or if this was 4, this was 3, it sees both of them. So these can't be 3, 4. So they're not 1, 2, they're not 3, 4, so they're 5, 6, and we know the order. That makes that 1 and 6. This is a 3 or a 4, but it can't be 4, so that's 3, that's 4, that's 3. That's 3 and 5, that's 2 and 5. This is a 1, this is a 4, and then down here we need 1, 2, 3, and 4. So the 1 goes here, the 2 goes here, the 3 goes here, and the 4 goes there. Nice. We get a DT2 right at the end. All right, cool puzzle, Chili. I liked that. Some really cool logic in there. There was always something interesting to look at, so we'd make some progress, another interesting thing, make some progress, another interesting thing. Makes for a great puzzle, but none of the deductions were too brutal, which was great. All right, so I hope you enjoyed this as well. And if you did, then why not leave a like, subscribe, and a kind comment below.